Alright, so the formula for the determinant is already up there, AD minus BC. So A times D in this problem would be what? Which is 42, good, minus, which is, very good. So here we'll have to keep, change. What's the determinant of this 2 by 2? That's it. Questions? We'll do one more together. Alright, this one, A times D would be what? Good. Minus? Good. So the determinant? Very good. Questions? Alright, do the other 3 on your own. That's 3, 4, and 5. On your own.
Sign up for it? I'll have a sign up sheet for tomorrow and it's free. You said show it? And it's coming November 18th. The last Thursday. It's the next ACT presentation. But it's only for math.
Alright, everybody done with those 3? Cool. Brianna, what'd you get for number 3?
36.
Everybody else get that? 36. Alright, Brandon, what'd you get for number 4? Did everybody get that? 114? Yes, very good. So, right here, this 14 times 3 would give us what, everybody? Negative 3. And then this would be minus 72. So that's why it's negative. Alright, and Bryant, what'd you get for number 5?
144.
Everybody agree? Very good. See how easy? I'm going to show you how to do these on your calculator after we get done with these 3 by 3s, okay? 3 by 3s are different, a little more difficult. You just have to follow a pattern, and I'm going to show you what that is over here. So go over here, and let's write a 3 by 3 matrix using letters first. So A, B, C, D, E, F, G, H, I. Go ahead and write that. I'm going to write the formula first on how to find the determinant of a 3 by 3. Then I'm going to show you the pattern. Okay? So write the formula first. I'll give y'all time to copy it down, and then I'll go over the pattern. That's the formula for a 3 by 3. Alright, we know what columns and rows are, right? So look at A. Tell me the column, or let's start with row. Tell me all the letters that are in the same row with A. A, B, C, good, same row. Tell me all the letters in the same column as A. Yes. So all of these, the first one, A, we are going to ignore the column that it's in and the row that it's in. And notice this little 2 by 2 matrix. How would I find the determinant of this 2 by 2 matrix? E times I, which is right here. Everybody see that? Minus F times H. Everybody see that? So they're taking A and multiplying it by this determinant. Okay? Then they're taking B. This next one is always going to be minus right here. always. So you're just taking the opposite sign. And I'm going to cover up the column, or excuse me, the row that B is in, and the column. See this little 2 by 2 now? So what is the determinant of this 2 by 2? DI minus FG. Everybody see that? Okay. And then the last one, C, it'll be plus, always plus. And I'm going to cover up the column and row it's in. So this determinant will be, go ahead, DH minus EG. Everybody see the pattern? Alright, let's get started then. So for number 6, tell me the first letter I'm going to write, or the number. 3. Now let's see if I can do it without covering it up. I'll cover it up the first time, sorry. Cover up the column and row it's in. Tell me how to find this determinant. It would be what? Negative 12 minus. Good. And it's always going to be a minus B. Well, this one's already minus, so it'll be what? Plus what? 2. I'm going to cover up the column and row it's in. Tell me the determinant. Minus negative 1. Good. And then it's going to be plus C, but this is a negative 2, so it'll be what? Minus 2 times, I'm not covered up this time. Tell me what's right.
0 plus 4.
Good. Because it would be a minus negative. Makes it a plus. Alright, so Alex, right here, I'll get what?
Negative 36.
Hold on. We're skipping a step. You got negative 36 because this is 3 times what right here? Good. That's what I wanted. Alright, Evan, this is going to be plus 2 times what?
1.
Good. Alright, Catherine, this is going to be minus 2 times what?
4.
Alright, so now, Nikki, this will be what?
Negative 51.
Okay. Sawyer, this will be what?
2.
Plus 2, and then William, this will be?
Minus 8.
Good, so tell me the determinant. Anybody? Everybody agree? Negative 57? Very good. Any questions about that? Let's try the next one together, and then you're going to do 8 on your own. Alright, tell me the first number to write. Times. Remember, if we cover up this and this, it'll be what right here? This way is going to be what? Minus
2.
Good. Everybody see that? Alright, tell me the next thing to write. Minus 1, good, it's always minus. Then what? Negative 3. Good. And then the last one will be what? Minus 4 times what goes in parentheses? 6. Go ahead. Plus 4. Good. It would be minus negative 4, but that would just change to a plus 4. Alright, find the determinant from here on your own. What'd y'all get? Still working? What'd y'all get? Good. Negative 63. Anybody else get anything different? Very good. Alright, people who don't have a TI 83 or 84, go ahead and get started on number 8. Those who do have a calculator, if you'll just follow along, I'll show you how to do the inverse of a 2x2 and a 3x3. Now the 2x2s, you know they're so easy, you wouldn't use a calculator, right? You can just do it in your head. So I'm going to show you how to do a 3x3. 2x2 is the same thing, it's just putting in a different matrix. So first you'll have to put in this matrix. So do y'all remember what to press to put in a matrix? Second matrix, go ahead and go over to what? Edit. I'm going to do mine for A. So you just type in 3x3 and then go ahead and type in all your numbers. And then kind of look up when you get done so I can know when to move on. You got yours in, Evan? Okay. Now hit second, quit.
Miss Horton?
Yes.
Was Logan Hunter in first period this morning?
Yeah, he had a pass from a
Okay,
teacher.
thank you.
You're welcome. Alright, so it should say a blank screen. Now go to second matrix, and now don't go over to edit. Just select that matrix A, or whatever matrix you use. And then you see the one that says x to the negative 1? That means inverse. That's the same thing as the inverse. So hit that button. Should say to the negative 1, then hit enter. Oh wait, I'm doing the inverse. I'm sorry. Clear that out. Clear it, clear it. Alright, now hit second matrix. I'm sorry. Go to math, which is the second column. You see where it says determinant? Hit enter. And now just put your matrix in. Sorry. So I'm going to put A in, then hit enter. And it should say 54. People who didn't use their calculator, did y'all get 54? Mm-hmm. So to find the determinant of a 3x3, it'd be quicker to use your calculator. But a 2x2, just do it by hand. It'd be easier, okay? Any questions? Alright. So that was 3.7. Everybody feels good about determinants, right? Cool. Now go to 3.8. These definitions might be on your test on Thursday. May or may not be on your test. The first one we haven't talked about, it's called the identity matrix. And it's a square matrix that when multiplied by another matrix equals the same matrix. So here's what the identity matrix looks like for a 2x2. It's just ones in the diagonal, everything else zeros. Same thing for the 3x3, ones going across the diagonal, zeros everywhere else. These are the identity matrix. And then you know the next one, so I'm going to let you fill that in. A blank matrix is a matrix with the same number of rows and columns. We talked about that was a what? Yes, square matrix. Alright, let's see. Skip down to here. Two n by n matrices are inverses of one another. That's what we're going to be doing in 3.8, finding the inverse. If they're product, so if you multiply a matrix and its inverse, you should get the identity matrix if you did it correctly. So that's how you check if you did it right. You multiply your matrix by its inverse, should give you this. We're not going to find the inverse of 3x3 matrices because it takes a really, really, really long time. So we're just going to do 2x2s for your test, okay? So here is the formula. I want you to draw a box around this or highlight it or whatever of the inverse matrix of a 2x2. And it's not difficult. I know it looks kind of messy. This 1 over AD minus BC, what is AD minus BC? What's that the formula for? The determinant, what we just found. That's why I wanted to do these together, because you have to know how to find the determinant. And then this DA, negative B, negative C, that's just moving these around. So what happens is you swap these, you swap the A and D, And then just make these the opposite signs, B and C. So you leave these in the same place, but you just swap the signs. And most inverse matrices, the inverse of matrix, are ugly. That include fractions. It's fine. It's not a big deal. Okay. Start by finding the determinant of number 1 on your own. So find the determinant. Don't use your calculator to don't plug in this matrix. It's just 2 by 2. What did we get for the determinant? What'd you get? 3. Very good. Do I need to go over how we got that? Okay. So here's the formula. It's 1 over this that we just found. So 1 over 3 times. And which 2 do we swap? Yeah, the A and D. So right here is going to go -1. Right here is going to go 7. Just swapping them. What are we going to do to these 2 right here? Yes, so this would become 5 and yes. And now all we have to do is multiply it. And I know this looks scary, but it's really not, because all of these have a what on bottom? A 1. Good. So all the tops we're multiplying by 1, correct? So they won't change. So the bottoms will just become what? 3. So this first one? Yep, -1/3. Next one? Come on. Good. Next. And that's it. Alright, I want you to go ahead, if there's no questions. You have any questions? Find the determinant of number 2 also, so we can go ahead and start. What did we get? 0? Alright, so for our inverse, we'd have to have 1 over what out front? 1 over 0. What's wrong with that? Correct. So when you get 0 for your determinant, the answer is it will have no inverse. So this matrix does not have an inverse. And just to go over how we got the determinant, this way we'd get what? And then it'd be plus 72, because, or it'd really be minus -72, right? Then you have keep, change, change. That's why it's 0. Alright, I didn't mention this, but going back to here, how could we check if this was the inverse again? Y'all don't remember? You multiply these and you should get what when you multiply them? Yes, this right here. I'm not going to make you do that, but if you have a calculator that can multiply matrices, I would check this. So go in and multiply these when you go to check it, okay? Moving on, go ahead and find the determinant of number 3. Alright, Darius, what'd you get? Just the determinant. -19. Good. Does everybody get that? So tell me how to set it up, somebody. Did somebody die? Y'all are being so quiet. Y'all gotta talk to me. Go ahead, Abigail.
1 over -19.
Okay.
And then -4, -7, -1, 3.
Good. Everybody see where she got that? You just swap these two, change these signs. So tell me the inverse.
So it would be positive 4 over 19.
Good.
Positive 7 over 19.
Mm-hmm.
Positive 1 over 19.
And
And negative 3 over 19.
very good. Questions? Alright, now I'll show you how to do it in your calculator. People who don't have one, go ahead and do number 4 on your own. Can I borrow your calculator? I'm sorry. Okay. Go ahead and type it in. You'll know you have to put that matrix in, so go ahead and be doing that. And once you get done putting it in, if you'll just kind of look up so I can know when to move on. Alright, hit second quit. Now hit second matrix. Go ahead and select yours. It should say A or B, whatever one you picked. And now use this button, the one I was showing you earlier, the -1 button. You hit that, -1, hit enter. And it gives it to you as decimals. I want you to put it as a fraction, so all you have to do from here, don't press anything, hit math. See where it says fraction? Hit fraction, then hit enter. It'll give you as fraction, okay? And people who did it by hand, make sure your answer is correct. Always make sure you can, if you can simplify a fraction, do that. So like right here, you simplified these. Make sure you do that if you do it by hand. Yes. Anybody need calculator help? Everybody's good?
Wait, how do you change it to a fraction?
Hit the math button now. And then hit enter. So there's the fraction. Enter. Alright, any questions about that one? Now, see what we got next, right? These fun equations that y'all know how to solve by hand. If you have a calculator, you don't have to do these by hand. I'm about to show you how to type it in and it'll spit the answer out just like that. If you don't, you better get working. Get to working. Start with number 1 and you'll need scratch paper because you won't be able to do this. But we're just going to do 1 and 2 today. So people who, and I'm checking these, so if you're doing it by hand, go ahead and get started because I'm going to check it before you pack up. Numbers 1 and 2. People who have a calculator, make sure you pay attention. I want you to write out to the side this as a matrix. Okay? And here's how the matrix is going to look. All of the coefficients, leading coefficients for the x's are going to go out front. So tell me the coefficients here. For just the x's. 2. And for the y's. For the z's. Go ahead. 3 and 2. And now for the equals 2. That'll be what? 1, 12, and -1, right? Type that one in. Go ahead and put that in your matrix. And this is a what size? 3 by 4, so you'll need to put that in. I'm going to put mine in for A. Bless you. People who aren't using their calculator, you can work together if you want. Let me know when you get done typing it in so I can move on. Okay, hit second quit. Now hit second matrix. Go over to math and see where it says well, let me see. Go hit the up button, and it should say RREF. I want you to write that down on your paper so you won't forget it. RREF is the button you're going to use. Does everybody see that on their calculator? Hit enter. It should say RREF parentheses. Put in your matrix. So second matrix. Select yours. And here's how you read this, okay? This is what it should look like. This is your X value. Goes in alphabetical order. Here's your Y value. Here's your Z value. X is -4. You'll write that over here. Y is 3. Z is 6. That's it. Now, let me show you this. See how this, without the -4, 3, and 6, is the identity matrix? Everybody see that with the ones going across? If yours doesn't look like this, you've done something wrong. Or either it's no solution or infinite solutions. We'll talk about that in a little while. But it should look like this, identity matrix. These are your answers, these last 3 always, okay? Try number 2 in your calculator. And people who are doing 1 and 2, I'll need to see that before you pack up. You need that calculator, I'm telling you. It makes your life easier, doesn't it? It's a good investment. You remember those ones that had 6 equations that we worked? And 5 equations? You could have used your calculator and spit it out. Raise your hand when you get done with these 2. I'll come check them. What you get? Here, you can pack up.